Hello everyone. So in this video, we're again trying to identify what language is denoted by a regular expression, and by extension doing something a bit more interesting with that language, namely determining what the shortest string is, right? So just to define this more rigorously, shortest string, by shortest string we mean the one or the ones, right? Maybe it's plural, with smallest length. Okay, so that's what we mean here by shortest. So if we apply the conversion of the regular expression to the language procedure in this case, we can kind of immediately do this on this regular expression. So we see that the regular expression that um, described or written down here denotes strings that start with A, right? So strings that start with A, and then where there's any number of BAs, right? So now hopefully you're starting to get a bit more familiar with irregular expressions and how they go from being a regular expression to denoting strings. So the star operator on the regular expression, what it's describing in terms of strings is any number any number of occurrences of the pattern BA, right? So namely the empty string, BA, 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 and so on. Okay, so here what this is denoting actually is strings that start with A and then that are followed with any number of consecutive BAs, right? So BAN for n greater or equal to 0. So that's the language denoted on the right here. Then the language denoted here is maybe a bit trickier. So we have the star operator applied to this bracket here, okay? And what the star operator does, again, right, so you can imagine this being translated to what it means for strings, right? So for strings, it means that every um, piece of the string comes from one of the members of the language. That's denoted by um, this guy, right? So that's what the definition of the star is for languages, okay? So that operation here, star, is applied to A or the empty string, the empty set star. Well, of the empty set star, right, that's going to be L of the empty set whole star, which is going to be the empty set applied to star, right? And so we know that this is the empty set 0, union the empty set 1, union the empty set 2, and so on. And so what this actually is, because for every language, L to the 0 is the set containing the empty string. This is the set containing the empty string. Okay, so it looks like what this is actually denoting, it's denoting a string that either starts with A or is empty, and then is concatenated with the empty string. So really, this is denoting A, right? So this denotes A. Then this regular expression just denotes the letter B. So this denotes the letter B. And then essentially what we have then is we have A or B or the empty set star, right? Well, the empty set plus anything, right? So in terms of regular expressions, the empty set doesn't actually um, denote any string, right? So if I apply L to this, then I get the star operator applied to L of A or B or the empty set. And then what that is, right, it's A union B union the actual, so let's write it like this, the actual set containing nothing, right? And so if we now apply this set operator, then we get A, B star, which is sigma star, right? So now, in fact, what we've just shown is that L1, which is the language denoted by this whole thing, intersect L2, which is the language denoted by this whole thing, is equal to sigma star intersect L2, right? But if you take the universe, right, so this is the universe, and now you reason about what the intersection actually does. So the intersection says the resulting strings in the set that comes from the intersection must be both in sigma star and in L2, but every string is in sigma star, so the filter is actually coming from L2. So in fact, this is exactly equal to L2, and so that means that this is equal to A to languages, to the language containing strings that start with A, and then that are followed with a sequence of BAs, right? And so then the shortest string, if we just list out the strings in this language by length, well, we have A concat the empty string, then A concat BA, so on. So clearly A concat the empty string, which is A, is the shortest string, which has length 1. So A is the shortest string. Okay, there we go.